Okay, we can start now. Is there any topic that you guys like want to go over in particular, or otherwise we can just start with the paper one practice.
Yeah, I think we should just start with the paper one, work our way down.
All right, cool. Yeah, so this one she did give us time to do in class, so I think I've done most of these. Okay. So I was thinking we can just like take turns like answering all of them. So I can go with the first one. It says the participants can answer questions in only one of the three following languages, which is Portuguese, Mandarin, or Hindi. 80 participants took part in the competition. The number of participants answering in Portuguese, Mandarin, or Hindi is shown in the table below. So the first thing is just state the number of boys who answered the questions in Portuguese. So that would just be the total of Portuguese, which is 38. And hold on. The boy, okay, I'm so sorry. The number of boys who answered the question in Portuguese, so that's this. It's 20. Sebastian, you want to do 1B?
Yeah, find the probability that the boy answered questions in Hindi. That be 5 out of 17.
So I got 5 out of 43. So it was kind of like find the probability that that the boy, so I thought it was like out of the total number of boys, that the boy answered questions in Hindi. So if you chose any boy, the probability that he would answer in Hindi, it would be 5 out of 43. Let me
All right.
open the key, see if it's correct. Yeah, 5 out of 43. So it would be like the probability that a boy answered in Hindi over the probability over like the total number of boys. Hiba, you want to do 1C? Okay, I don't think she's there. I'll just do it. Okay, that's okay, Hiba. I can do this one. So it says 2 girls are selected at random. Calculate the probability that one girl answered questions in Mandarin and the other answered questions in Hindi. Okay, so the first time I did this, I got it wrong because apparently we're supposed to so the correct way to do it is that first like let's say like one girl was chosen who answered it in Mandarin, so that would be 12 out of 37, right? Because there's 12 girls who answered. Sorry, 7. It would be 7 out of 37 because 7 girls answered in Mandarin out of a total of 37 girls. Then after that, if a girl is chosen who answers it in Hindi, it would be 12, but it would be out of 36 because one girl was already taken out of the group. So you would multiply 7 over 37 times 12 over 36, which is 84 over 130, 84 over 1332. And then you have to do it like the opposite way. So if first you chose a girl who answered in Hindi, so it would be 12 out of 37 times 7 out of 36 because the second girl would be speaking Mandarin. So if you multiply 12 over 37 times 7 over 36, you get the same thing, which is 84 over 1332. So then you would add together both of the probabilities of like both of the variations of how you could get one girl speaking Mandarin and one girl speaking Hindi. And so the answer would be 168 over 1332. I'm pretty sure that's correct. I think I just haven't simplified it. Let me check. Yes, it's the same thing. It was just different by a factor of 12. Okay. 2A. Sebastian, you want to do this one?
Sure. Write down an expression set notation for the shaded region represented by diagram 1. Okay. So I see it's all of A. So maybe
I think it's the shaded region is everything that's not A. So the shaded would be like the gray, right? So A isn't shaded.
A prime then.
Yeah, I think it's A prime. Let's check. Yeah, that'd be A prime. Okay, 2B. Hiba, do you want to try this one or no? Okay, I'll go ahead and do it then.
Lois joined too.
Oh, okay, great. Hi Lois, you can try the next one then.
2B.
Mm-hmm.
For this one, I put C union D prime because basically the only part that's not in C would be, or the only part that's not shaded would be the D, and it kind of makes sense for it to be like D prime.
Yeah, I think it would actually be intersection because D prime.
Oh yeah, sorry.
Yeah, okay. So it'd be D prime intersection C. Let's see what's correct. Yeah. Okay. 2C, write down an expression for the shade region in diagram 3. So okay, for this one I put all of G union with E intersection F. So the E intersection F would be in parentheses, and then union with all of G. So yeah, that's the same thing it says here. Sebastian, you want to do this one? 2D?
Yeah, for this one, I just shaded everything outside the 2 circles.
Yeah, me too. Yeah, just like that. Okay. 2E, it's J intersection K. Okay, so I just shaded all of K, just the small circle, because it would be like J and then K, but only where they intersect. So yeah, just like that. Okay, Lois, do you want to do 3A?
Yeah, sure. For this one, I put on the after like green white, I put the probability of that was 3 out of 7, and then for white green, I put 5 out of 7, and then white white would be 2 out of 7.
Yeah, I got the same thing. 3 out of 7, 5 out of 7, 2 out of 7. Yes. Okay. Okay. So this one says find the probability that exactly one of the selected balls is green. So for this, I did, so first I found like the green white and then the white green, because those are the only two where only one of them is green. So you multiply like 5/8 by 3/7, which is here, and then add 3/8 multiplied by 5/7, which is here. And then so the final answer I got was I think it was 30 out of 56.
Yeah.
Yeah. Okay. Okay. Sebastian, you want to try this one?
Yeah. Group of 20 students traveled to a gymnastics tournament together. Their ages and years are given in the following table. Wouldn't I just plug this? Oh, this paper 1 though, right?
Yeah, so we can't use for this one.
Find the mean age. We have to do it the long way. No. Yeah, we would, right?
Yeah, we would.
Well, if I remember correctly, it was like 16.5.
I got, so basically wouldn't for this one we would just basically try to multiply like 15 times 2 plus 16 times 7 and
Yeah, you multiply each one by the frequency.
I
Um,
got 17.5.
yeah, I
Yes,
think
that's correct. Yeah.
No.
I
Drop it.
yes, 17.5. Okay, for B, for the students in this group, write down the median age. For this one, I got 16.5. So the total, I think the total was 20. Yeah, it's 20, it's 20 students total. So we divide that by 2, you get 10. So there's no like number that's exactly in the middle. And so then 7 plus 2 plus 1, that's 10. And then all of these also equal 10. So you would have to average 16 and 17. Because 16 is where the 10th number is, and then 17 is where the 11th one is. So I got 16.5. Yes. Okay. Lois, do you want to? I don't know for this one. I don't know. I guess you could show us the graph you got, or
I actually don't know if I got to that one.
we can just look at the answer and then just see if it looks about right. Yeah. So the minimum age was 14, so that would go there, and then the lower quartile was 16, and then the median was 16.5, like we found out before. Or hang on. Yeah. Okay. Yeah. The median is 16.5, and then the upper quartile, I think they gave that to us, right? Yeah, it's 18.5. So then
Oh, okay.
that would go right there. And then the maximum age is 22. So then the last line goes there. So yes.
She's not gonna ask us to draw anything like that, right? For the
I don't
test.
think so. I think she said for the test, we're putting it all like directly into Schoology, right? So I don't think we
Yeah.
can. I don't think she would draw.
I mean, like if it's like her old tests, then we probably, I don't know, like we're probably gonna type our work in, but I think if we had to look for a graph like this, it would probably be multiple choice, and then we'd have to choose which one.
Yeah,
would
that makes sense.
correspond.
They had several of those on Cognity too, I think. So it might be like those. Okay. Um, okay, so the graph shows the person's age in years versus hours they spent watching television. And the mean age was 50, and then that's the regression line, H on A. So it says find the mean number of hours that the people surveyed watch television per week. So since it gives the mean age, here, so I think there was like something called the mean point or something like the average point or something like that, right? So so then I saw where like I put 50 into like this line, and then whatever I got out was the answer. I think it was 26. Because that would be like where 50 is on the line of best fit. Yeah, 26. Sorry, Lois, I keep interrupting you. Were you gonna say something?
Oh no, you're fine.
Okay. Okay, so this one says draw the regression line on the scatter diagram. I kind of just did like a rough drawing on my paper. I found where the y-intercept would be, and then I found where it would be at 80, and then I just drew a straight line instead of like making a grid.
I think on one of her practices, or like the practice questions we had in Cognity, one of the graphs, like it didn't really have like a mean point, but you had to choose the line where it like divided all of the points like equally. So if there were like 10 points on the graph, then the line had to be where there were 5 points on each side of the line. I think it's the other way, like if we're estimating.
Yeah, that makes sense. So then I guess like when we would be drawing the line, we have to keep that in mind too. However many points there should be like the same number above the line and below the line. And I think that's probably gonna be a multiple choice. I don't think she's gonna make us draw that. Okay. Sebastian, do you want to do 5C?
I put a check mark on the first box, the positive correlation.
Yeah, me too. If there was no correlation, there wouldn't be an equation. So that one doesn't really make sense. So yeah, it's just the first one. Lois, do you want to do the last one?
Sorry, I'll be right back.
Okay. It says Diogo is 18 years old. Give a reason why the regression line should not be used to estimate the number of hours he watches television. So the least age is somewhere around 25. It definitely doesn't go as low as 18. So since
Yeah.
that would be extrapolation, it's outside the X range like shown in the graph. So it's not valid. I think that's it for paper one. Is there anything that we were confused about, or we can move on to the next one?
We can move on.
Okay, cool. Okay, paper two. Cumulative frequency curve. A transportation company owns 30 buses. The distance that each bus has traveled since being purchased by the company is recorded. The cumulative frequency curve for these data is shown. Okay. So the first question says, find the number of buses that traveled a distance between 15,000 and 20,000 kilometers. So I just found the number of buses that traveled under 1,500, which was, if you go up here, it's 20. And then the number of buses that traveled under, what was it, 20,000? So if we go up here, that's 28, I think. Yeah, I think, okay, yeah, it's 28. So then you can just find like the difference. And so I got 8 buses. Yeah, it's 8 buses. So the first point is for just like writing down the 28 and the 20, and then if you get the correct answer, that's the second point. 1B says, use the cumulative frequency curve to find the median distance. Hua, do you want to try that? I don't know if she's here. I'll just go ahead and do it. So to find the median distance, we would first take like the cumulative frequency and then divide that by 2. So since it's 30, it would be 15, and then we find the point that corresponds to 15. And then here, each of the smaller lines, they're 500 apart. So then if you find the one for 1,500 or 15,000, just 15, if you find the one that corresponds to 15, it's 13,500 down here. So yeah, okay. Sebastian, you want to do 1C?
Sure. So the lower quartile, we do the 30 times 0.25, and we get 7.5 as the lower quartile on the cumulative frequency side, and we just trace that over to whatever distance it is.
Yeah, so 7.5, it's right between here, so then it would be 10,000.
10,000, yeah.
Kilometers, yes. Okay. 1D, find the upper quartile. So same thing, you would just multiply 30 by 3/4 and you get 22.5. So that's right here. And if you trace it all the way to the bottom, you get 16,000 kilometers. Yeah, so it says that they would accept anywhere from 16,000 to 16,250. So I think same here. So you have like, you would take about 250 for error. Okay, so in the interquartile range, you would just subtract those two. So it'd be 16,000, which is upper quartile, minus 10,000, which is lower quartile, and you get 6,000. Yeah, so that's just 1 point. Yeah, okay. Okay, 1F.
Paper 2.
Yes, we're doing paper 2.
Okay.
Lois, do you want to do this one, or are you opening
Yeah,
it?
sure. For 1F, I did so I found so basically the upper quartile that we got was 16,000, and then it would be 22.5 buses. And so I subtracted 22.5 from n, which is 30, and I got 7.5, and I divided by 30, and then that's 25%. But basically it's because it's a quartile, so it would be
Yeah.
technically a quarter. Yeah.
Yeah, I agree. Yeah, I started doing the math too, and then I was like, it's a quartile. So yeah, it would be 25%. Yeah, so it's correct. Next one. Okay. Find the number of buses that traveled a distance less than or equal to 12,000 kilometers. So then you would just go here, find the number here, and then just trace it up. And then I got 11 buses. So yeah, that's correct. Just 1 point.
And I think for the graph, I thought the graph went by like 500 on the bottom, and then by 2 on the side.
I think each like big line is 2.5.
Oh yeah.
And then so each of the smaller ones are 0.5, I think. And then the x-axis is 500, yeah. Okay, the last one. It is known that 8 buses traveled more than m kilometers. So find the value of m. So you just do 30 minus 8. So we're saying that the top 8 buses, right, would travel more than that. So then you would just find 22 wherever it's, I think it's right here, yeah, because that's 22.5. So it would be right here. So you would just trace it out and then see what number you get here. And I think it turned out to be 15,750 kilometers. Yeah, and then you have like a little error range of 250. But the first point is for just like recognizing, like having the 30 minus 8 and then getting 22. Okay, same thing. We were just drawing a box and whisker diagram for this. We can just look at the answer. So the lowest, like they said, was 2,500, and the highest was
I think the highest was 23. Yeah. Sorry.
Yeah, 23,000. So that's right there. They said to use a ruler on these. I don't know. Yeah, it said use a scale of 2 centimeters to represent 5,000 kilometers. So when I was drawing it, I did use a ruler, but I really don't think we're gonna have to do that during the test. And then the median, I don't know if they gave that to you, but you could find that out easily.
I think it was one of the things that we might have found in the earlier question.
Yeah, I think it was 1B. It was 1B. So it was 13,500, and then we found the upper and lower quartiles as well. So you could just put that on the graph. Okay, 2A. Liz, do you want to do this one?
Sure. Paper. So it says to write down the value of A and B, right? So wouldn't you just plug this in for the to the calculator?
Yeah. And then once you plug it in, I think you go to linear reg, right? And then it just tells you. So yeah. So what did you get for A and B?
Sorry, I'm still plugging it in.
Okay.
So for For A, I got 6.96, and then for B, I got negative 454.81.
Yes, that's right. Since this one was 3 points, I wasn't really sure what to do to like get all the points. So the first thing it just says evidence of setup. I'm not really sure what it means by that, but then I think you get 1 point for having like the longer numbers written out. I think you need at least like 5, and then you can put dot dot dot, and then you get 1 point for just rounding it to 3 sig figs.
So it's 1 point for each of the unrounded, or
I'm not sure because here it says the first point comes from evidence of setup.
Yeah, I think like on her previous tests, like what I would do, and she would give me full marks for it, is like basically you write down the entire value that's like that shows up on your calculator, and you just write that down, and then you write the rounded version. So you write the raw version, and then you write the rounded version, and then she gives you the marks.
so it's 1 point for having both of the unrounded, and then 1
Yeah,
point.
and then
for
1 point
the
each for
correct
the
ones.
Yes. Okay. I think once we finish number 2, we should go on to the other ones. We can go to probability and then statistics, so we cover everything. Okay, so for 2B, it says use this regression line to estimate the monthly honey production from a hive that has 270 bees. So for this one, you would first you have to like write down the whole equation with the unrounded numbers, or at least have like the dot dot dot, and then show that you plugged in 270. And then I usually just like show the steps. So I show like A multiplied by 270, like the whole unrounded number, and then I put minus like whatever B was. And then the unrounded number for the final probability, and then the rounded number. And then the rounded number always goes to 3 sig figs.
Hey Prachi, I think your audio is kind of choppy. So I didn't quite understand you.
Can you hear me okay now? Can you guys hear me now?
We can hear you. It's just like kind of weird.
Let's see what I can do. Okay, so I said before that you write out the whole equation like with the unrounded values. So you would write like the whole like unrounded value of A, or not even the whole thing. You just have to, I think you just have to have at least like 5 or 6 numbers, and you can put dot dot dot. So put the whole like P equals A times 270 minus the whole number for B, and then you just kind of show your steps. But the last number, you have to write it unrounded and then round it to just 3 sig figs. So that would be 1,420 grams. Okay. Sebastian, do you want to do this one? 2C.
Oh, Prachi, I actually had a question. So
Yeah.
for like I wasn't sure like how to do like some of the questions. Like I know she always tells us to run to 3 sig figs, but when it's it's not it's not just a decimal and there's like a whole number, do we still round like the decimal values into sig figs, or do we just round it to a whole number?
Round it to the whole number.
Yeah,
Even
you
if
just
it cuts it out.
Just round to whatever gets you 3 sig figs. So I mean, technically, if you round this first, you would get 1,425, but then you still have 4 sig figs.
Okay.
Or actually, then shouldn't it be 1,430? If it goes to 1,425, then it should round to 1,430.
Yeah. So that's why I was a little confused. I don't
Or
know. Maybe
actually, yeah.
Maybe they just rounded to
4.67.
4.
Yeah, 4.67 is technically less than 5, right? So it would actually go to 1,420. That makes sense. Does that make sense?
Yeah.
Okay. Okay, 2C. Sebastian, you want to try this one?
Yeah, so I got 40, an interval of 40 for the honey. So it's also the number of low production hives. I got 40 as well.
Right, because that would be anything less than the 1,000,
1080. Yeah.
1,080, so that'd be 40. Yes, so 2C would be 40. And then we know that 128 are regular. So then we just do, we find like where 1,080 is, so that was 40, right? And then we add 128 and then find like whatever that number is where it corresponds to the production of honey. And so that would be like the highest production.
Hey, Prachi.
Mm-hmm.
Could we go over some of the presentation questions? Because I know she said those were the ones that she like kind of handpicked, and so
Yeah.
those might be the ones similar. I didn't get to go over them, so I wanted.
Yeah,
to
I didn't
know.
get to go over those either. Yeah, I think we can just like stop now. We can go to those. Let's see. So the probability ones?
I think so.
Yes, I think this one is presentation. Probability distribution is something I'm not great at, so I don't think I'm going to be able to explain those. Okay. The first one, two independent events, A and B, are given such that probability of A equals K and the probability of B equals K plus 0.3, and the probability of A intersection B equals 0.18. So first we need to find K. So if we have A intersection B, we know that so the probability of A union B would be probability of A plus probability of B minus the intersection. So we would get the union is equal to 1, I think, right? Always.
If it's decimals, I think it's 1. But for this one, I don't think you do the equal to 1 because it's two independent events.
All right, for the independent events, you just multiply. So then, so for the,
oh, sorry. Go ahead.
Go ahead.
No, sorry. You can go first.
Okay, for the intersection, I think it's just probability of A times the probability of B, right? Okay, we're gonna assume that's right. So then you would do K times K plus 0.3 equals 0.18, and then you would solve from there, I think.
So I'm kind of confused because I thought that you could find actually never mind. Sorry.
Okay. Okay, so then if we would write this out. So we have 0.18 equals K times K plus 0.3. So if we multiply that out, we get K squared plus 0.3K. So we can turn that into a quadratic equation. I'm not sure that's what she wants us to do here. Seems kind of complicated. Does she have the answers for this? I think she does.
I think I'm not sure because I'm not really that good at probability either. But I think she said we were allowed to use like the equation sheet during the test. So I'm not sure if there's an equation maybe for it.
Right, I had that open here too, but I wasn't I think the ones I were looking for are like way down here because I had to scroll for a long time, couldn't really find them. Let's see. Here we go. Okay, so for independent events, yeah, so the intersection is equal to them multiplied. I think we have to put into the quadratic equation. I'm not really sure how else you would, because right now we have
I did this one and it's not the quadratic either. At least I don't think it is.
so how did you
I think
solve
she
that?
showed some work. I went over it, but I still had questions on it. I didn't really understand it.
Okay, let's look at her answers. Okay, so A, right, so it's just multiplying, that's what we were doing. Right, so she got the same equation that we did. So she said to check the zeros. Oh, okay, so I think she put it into the calculator. Did she? Or maybe she just plugged in 0. I think maybe she just plugged in 0 for this. What do you guys think?
I think so too, because she has the x-intercept. Or yeah.
Yeah, I don't know. Are we allowed to use our calculator for these?
I think so. I mean, she didn't really specify if these types of questions would be in paper 1 or paper 2. So I'm guessing because she drew the graph that it would probably be allowed on the calculator.
But yeah, because the thing is, if you just plug in 0, then you get 0 minus 0.18 equals 0, and then that doesn't make sense. So I think you would have to put this in your graph, or you could use the quadratic formula. I think that would work too, but I think the graph is a lot faster, and I graphed it, and yeah, it shows the same thing. So I think you would just put it into your graph, into your calculator, and then look at the graph. Okay, so B says find the probability of A intersection B. So okay, so for that one, you use the same formula that we do like normally, like even for independent, even for independent events, you use the same formula like this one right here. So probability of A intersection B. Probability of A union B equals probability of A plus probability of B minus the intersection. So then I think we can just plug in what we know, because we know that K equals 0.3. So A is 0.3, and the probability of B is 0.6, because it would be 0.3 plus 0.3 minus 0.18, and so you could just solve, and then you would get 0.72. And then for C, probability of A prime over B prime. I don't know how to do conditional probability. Okay, so for the second number, it would just go on the bottom, like just that probability, and then on the top would be the intersection. So we know what the intersection is. Or actually, wait, first we have to find A prime and B prime. So it'd be 1 minus 0.3 would be A prime, and then same for B prime, so you get 0.4. And then you do the intersection, which is the multiplication, right? So you'd get 0.7 times 0.4, which is 0.28, over the probability of not B, because or a B prime, because that's the second number. So 0.28 over 0.4 would equal 0.7. Or I mean, if we usually what I do is that if the top is 0.7 times 0.4 and then the bottom is 0.4, then the 0.4s cancel out like on the top and the bottom, so you don't actually have to multiply the top. You just get 0.7 because that's the only number left.
I think the reason that she does that though is because it's not usually, it doesn't always work, like it doesn't always cancel out, so
yeah,
I think that's probably why. So I understand like how you found B and C, but I'm still a little confused on like what she did to find K, because I got to the equation part, but I'm not sure like how she found K on the calculator.
So okay, so if you go to y equals, you can just like write in the equation. So you can just replace K with X. So you just put in X squared plus 0.3X minus 0.18. And then you go to graph. And then you click on second trace. So the blue in blue, it'll say calc. So if you go there, and then so the second thing, it should say 0. So you go to 0, and then you click on enter. And then first it'll say like left bound. So you do like what you think is like the left side of the 0. And then you do right bound, which would be the right side of the 0. And then you try to like guess exactly where it is. And then you just keep clicking enter, and then it'll tell you what the 0 is. Does that make sense? I can show it to you on my calculator if that's easier.
Yeah, please. Sorry, I'm a little
I can do
lost.
that. Okay. So first you just like, I don't know what it's gonna show. Okay. I don't think this is working. I can send you pictures.
Okay, thank
of
you.
how- Yeah. That's it for today, guy. I think that's time. I think we have to stop now.
Well, thank you, Prachi.
Thanks,
Yeah, of
Prachi.
course. Bye, guys.